Ever stood in front of a mirror and wondered, what is it really that you're looking at? Is it this mystical portal reflecting your soul? Or is it just a simple slab of glass? Prepare to be amazed because mirrors hold more secrets than you might think. Welcome to this episode of Scientific Facts. Today, we are peeling back the layers, or should I say the reflections, of the science of mirrors. Did you know that for centuries mirrors were thought to have magical properties? In ancient Greece, people believed mirrors could give you glimpses into your future. Fast forward to today, and even in the scientific community, the properties of mirrors lead to certain misconceptions. Let's shake up those misconceptions and dive into real science. Now, before we move forward, there's a question that has puzzled many. Why does a mirror seem to reverse left and right but not up and down? Have you heard of it? Hold that thought. We'll unravel this mystery in just a moment, but first, let's talk about what a mirror actually does. A mirror, as simple as it looks, is a game changer in the world of optics. Did you know that when you stand in front of a mirror, you aren't seeing yourself but rather the light your body reflects? Yep, it's true. Mirrors simply redirect photons, those tiny particles of light, helping our eyes see an exact replica of whatever the light just hit. Sounds straightforward, right? Not quite. Show a demonstration of a light beam hitting a mirrored surface and reflecting in another direction. The surface of a mirror is designed to reflect as much light as possible, rather than absorbing it. That's why mirrors are often made out of a highly reflective material like aluminum or silver and then coated with glass for protection. Without that special reflective coating, you'd just have a plain piece of glass. But let's get back to that puzzling question. Why does a mirror reverse left and right, and not up and down? Here's the key truth. Mirrors don't actually reverse left and right. Say what? Yes, you heard that right. Next time you're in front of a mirror, raise your right hand. Your mirror image also raises its right hand, so where's the reversal? What's happening is that the mirror is flipping you front to back, not left to right. To explain this better, imagine yourself holding a transparent mannequin in front of you. If you turn that mannequin to face you, it is effectively flipped front to back. Exactly what a mirror does. No magic, just physics. Pretty mind-boggling, isn't it? Still with me? Let me blow your mind even further. Did you know mirrors don't actually make images? Yup, they simply reflect light. What we perceive as an image is actually our brain's interpretation of how light behaves when it bounces off a reflective surface. This ties into a branch of science known as optics. The mechanics of mirrors have been pivotal in advancements like telescopes, microscopes, and even the rear-view mirror in your car. Imagine if mirrors didn't exist. How would you even parallel park? Here's another shocker. The quality of reflection depends on the smoothness of a mirror's surface. To produce a perfect reflection, the coating has to be smoother than 1/1000th the thickness of a human hair. Incredible, right? And it's not just about the practical benefits. Mirrors are also portals to illusions. Remember the classic amusement park mirrors that make you look tall, short, curvy, or wavy? Those aren't just fun tricks, they are lessons in geometry and light behavior. Curved mirrors manipulate angles to warp reflections. For example, a concave mirror converges light to a focal point, which is why it's used in magnifying glasses and telescopes. Conversely, convex mirrors scatter light outward, giving a wider field of view. That's why they're used in street corners or security cameras. But wait, there's more to mirror magic. Imagine the last time you tried on sunglasses. Believe it or not, those high-tech reflective coatings owe their origins to mirror science. Metallic coatings on sunglasses reduce glare by reflecting specific wavelengths of light while letting others pass through. These are known as polarized lenses, and they wouldn't exist without our understanding of reflective surfaces. So, by extension, mirror technology isn't just about reflections. It's about optimizing how we see the world outdoors, too. Now, let's step into cutting-edge territory. Modern science is exploring ways to build quantum mirrors. Yes, you heard that right. Instead of reflecting visible light, these mirrors would reflect particles at a quantum scale, like atoms. Just imagine future quantum computers using mirrors to redirect particles for superfast processing. It's an exciting frontier. Lastly, consider this parallel. In philosophy and psychology, mirrors often represent self-reflection, pardon the pun. But mirrors also force us to see reality as it is. Unlike a camera lens, a mirror shows you how everyone else perceives you. No filters, no Photoshop. It's raw, unfiltered you. And isn't that the most fascinating reflection of all? Before we wrap up, let's recap. Today we discovered that mirrors aren't reversing left and right, but flipping front to back. We also uncovered the incredible journey light particles go through to create our reflections. And finally, how mirrors from ancient times to modern technology shape our world and perceptions. Mind-blowing, isn't it? Mirrors aren't just mysterious. They truly are a reflection of science in its finest form. Thanks for joining us on this thought-provoking journey through the glass. Don't forget to subscribe and hit the bell icon for more amazing facts on the next episode of Scientific Facts. Until next time, keep reflecting on what you've learned.